get started with some intros and setting the stage for folks. So I can go ahead and start. Hi, everybody. My name's Adam Azam. I'm VP of Product at Prefect. Prefect is a workflow orchestrator. We started in 2018, really for ML engineers and data scientists who were trying to do more dynamic Pythonic workflows, and we're not finding that existing tools at the time like Airflow was really up to snuff for them. Over the last few years, through a lot of different iterations, now have probably one of the most popular workflow orchestrators in Python. Folks come to us a lot for doing event-driven orchestration. If you don't want to just run stuff on every third Thursday of the month when like there's a full moon and you want to do it like when a user signs up, when somebody sends an event, I want to go kick off a pipeline. And then folks that really are orchestrating data pipelines, folks that need to be able to share data between independent executions of different workflows that might not be children of each other. You can imagine different ML pipelines that are trying to, not try to like clean the same data set or impute the same features twice. And so, over the last few years, we've seen a lot happen in orchestration. And I think one of the things I'm most excited about is just seeing the Python ecosystem really invest heavily in like the actual data lakehouse layer. I think that one of the things that motivated this webinar is Chiro, who I'll introduce here in a second, is Chiro and I were talking a long time ago about like if you're trying to do like very adult data work, it always ends up meaning that you have to like pick up Spark at some point in time. And if you're trying to keep it all in Python, it means you have to pick up PySpark. And you take that syntactic sugar cube, you feel like you're all working in a single language until that thing crashes, and then you find yourself like woken up into your real nightmare that you've accidentally sewed Java into your stack. And so Chiro I met a number of years ago, who I think is like probably doing the greatest act of service and love and building an incredible product and business around how to build a Pythonic data lake, not just a Pythonic sugar over some Java data lake, like something that was engineered from the ground up, from how do you keep sort of all of the power, flexibility, robustness, and scale of systems like Spark, but how do you do it in the actual lingua franca of people building data pipelines? And so I've followed Bauplan super closely, and they're a team, a product, and a business that I really admire. And so we're real kindred spirits here. I think we think about orchestration a lot in the same way. We think about developer experience a lot in the same way. And so I'm super excited to have Chiro Greco from Bauplan to talk about Bauplan, to talk about the problem that it solves, the motivation that they had in building the company. As far as today, the sort of agenda before I turn it over to Chiro is Chiro's going to talk a lot about Prefect, talk about Bauplan. We're going to go through an example of them working together, and then we're going to have some time for questions at the end. I'm going to interrupt. Feel free to throw in some questions. I'll be looking at questions throughout. This is not a we talk at you for like the next hour sort of thing. And so our preference is as questions come up, feel free to lob them across, and then we'll go into it. Without further ado, excited to pass it over to Chiro. Chiro, welcome.
Well, thank you very much. It's great to be here. And yes, I think like we can consider this kind of like the Python brigade or something like that. So like this alliance around the idea that we can do a bunch of things in a kind of like simpler way. Yeah, I think like, so today we can like the plan here is to mostly talk about, I think like what is a tension between the orchestration layer and your control plane and data layer when you actually operate systems that process data pipelines in the cloud. And in like to your point is this kind of idea that Python is for boys and like Spark is for grown-ups when it comes to like running data jobs in the cloud, and more generally speaking, kind of like JVM based like distributed engines. But then it creates like this kind of like cognitive dissonance between your orchestration layer that, thanks to companies like Prefect, that has become like truly like, you do have Pythonic options out there. Like there's no excuse there. And then the rest, like there's this kind of like disconnect more downstream on what you see when in the execution layer. So you should be able to see our presentation. And so basically, as I said, like what we're going to talk about is this, like, is how we could reconcile around like the idea of building like a really Pythonic data platform that is like that manages also the runtime and the data management piece in a way that is not just like a thin coat of paint on top of essentially Spark or generally speaking a JVM. Our definition of a data pipeline is fairly kind of simple. Is just like a bunch of defined processes that take some data as an input, do some kind of cleaning, joining, enriching, like some transformation over the data, and then dumps the output back into your storage layer. And then you do that like as many times as you need, like to go from usually your raw data you collect from your systems to whatever artifact is in a shape that you feel confident enough can be used by a downstream application. So, like it can be a machine learning model that needs a training set. It can be a dashboard that needs like some art, or it can be AI applications these days that maybe need like some training data sets that has gone through like deduplication and cleaning to do fine tuning and so on. And like the job of orchestrating this, like of course, like as you know better than anybody else, is about like having a good way to schedule and then have a way to understand how the whole logic in case things don't go as expected can be executed. So retries or like rollbacks and a layer of observability that helps the developer understand what happens. Data pipelines fail for plenty and mysterious and sometimes unfathomable reasons. They tend to become like fragile and gnarly objects that can take a lot of your mind share to be maintained and operated efficiently. And so modern orchestration actually happens in Python, and like Prefect is of course like is possibly the most Pythonic thing out there. The Bauplan team like chose you guys as the orchestration layer several times in different moments of our lives when we had to build pipelines at scale. So we're very fond of your product and your abstractions. But basically, the concept I think is and I'll let you elaborate if I miss something. But like the way I see Prefect is that traditional orchestration often requires you to define the flow ahead of time as a static graph, like as a DAG or fixed task with fixed dependencies. And Prefect just like is super dynamic, and you just like work in Python, and you get like the normal control flows and loops and branching and conditionals and like everything you get out of Python, you get in your orchestration layer. And it's really just like writing a bunch of Python functions you sandwich between this lightweight decorators. There's no predefined or rigid DAG definition or specialized DSL like the domain specific language. And because of the flexibility, you can generate tasks at runtime depending on data or other conditions. Like you can handle conditional logics again, like with the same flexibility that Python gives you without fighting the orchestrator. So you can embed, I don't know, dynamic behavior like, oh, this task is gonna run only if certain external data meets some conditions, right? Or you decide at the runtime how many tasks you need or how large is the machine that downstream it happens. And no, it happens like very dynamically. And the way in which Prefect wraps this as a basically kind of like a state tracked execution model, which is effectively a state machine, helps monitor and like manage and monitor the whole execution. So this kind of gives you observability out of the box. You can watch when tasks run, when they fail, when they retry. It's very easy to inspect the history, get alerts, like debug failures, and monitor the performance and health of your entire system. It's like this is a very flexible and powerful way of thinking about your orchestration layer. And I guess like the main argument that we want to make here is that modern orchestration definitely happens in Python. The more Pythonic your framework is, the more flexible you get. Python is also the top language for data science, machine learning, and AI, which are the kind of like the disciplines of data these days. And outside of the fact that I think like Python is just like simpler and more expressive and easier to pick up than you know, more low-level languages like C++ or Java that are also used like for data. I think like one of the big advantages of using Python for this stuff is because you can do like pretty much everything with it because there's a very rich ecosystem. So you can do, I don't know, like vectorized numerics using NumPy, and then you can manipulate like tabular artifacts with pandas, or these days probably polars more, even more so. You can do machine learning with scikit-learn, deep learning with PyTorch and TensorFlow. So it's a very rich ecosystem that allows a data practitioner to do like a wide variety of things, like using just like Python. And the problem there is like what we was mentioning in the beginning, is that orchestration is super Pythonic. You do have a very rich ecosystem to work with your data potentially, but in my experience, when things like work at scale, the general wisdom is that you're going to transition from this like more Pythonic way of doing things across the board to including Spark clusters and JVM stacks and a lot of infrastructure in the data, in the control plane, in your data layer, that needs to talk to your orchestration layer that's higher up. And most of the reason for that, like, it's not like, I mean, we do think this is no longer true, and we do think that there should be a better way, and we built that better way. But it's not like this happened for no reason at all. Like, is because like effectively a lot of your data layer in Python has been like super rough around the edges for years, right? Like you kind of lack most of your uh, optimization that matter when you do things at scale. Like this is an example, for instance, from an AWS implementation guide. Um, Usually, like your data layer when you use like Python is just a bunch of files in a bucket, which is not great because like you kind of like can read like a bunch of CSV files or Parquet files directly in the memory of your process using something like pandas. It's not exactly efficient. Like that's not what I expect when I typically do data at scale. If I use data on an SQL engine, I expect the engine to be data aware, and so be able to do like filter pushdowns, predicate pushdowns, be optimized and not read one single byte ideally that we don't have to read, which is very, very different from the experience that most data scientists especially have when they run like pipelines or just like notebooks with Python in the cloud. The other problem is like you lack all the ergonomics. If you stay on this way of working where it's like very tied to the abstraction of files, there's a lot of the nice things of working with optimized tables that you need. Like data versioning is one that is particularly dear to our heart because it's very useful when you try to do things in a production system. Like let's say, for instance, that you have a data pipeline that takes some data and then asks, like takes this data and asks an LLM to read the data and do some data enrichment. This is a pipeline that we see very often these days in production at Bauplan. Like this is something that our customers like do every day. And it's perfectly reasonable to have like the curiosity of like running different models to see what's better. And you try like the same pipeline with, OpenAI, and then with Google, and then with Anthropic, or like the same model over different versions of the data. So you want to try like this kind of like combinations. And if you do that just with files, all you have is like you probably have to revert onto this kind of like Byzantine name conventions, which is like very much like less than ideal, than just like having built-in time travel and data versioning. So I think like these are like mostly the reasons why the lack of optimization of and this like the lack of built-in abstractions to work with data that are very helpful when you process large amounts of data or just manage complex production systems is the reason why the general wisdom is you should not do Python. You should kind of like do JVM based engines rather than just like running Python like naively in the cloud. Now the good news is that in the data world, a lot of what I just described is changing very quickly around the concept of the data lakehouse, which is effectively a design where you maintain the fact that your storage layer is just a bunch of files in S3, but you interact with your data using these logical tables that are created by open table formats like Apache Iceberg. which is kind of like not really like a storage format. It's more like a format that you use to represent data that is stored as a Parquet file most of the time, but it's not represented as a table. And so you get like all these the nice things that you have when you work with a table. It's optimized if you run a query against it. You have ACID guarantees. You have schema evolution. You have built-in versioning. So you stop working with this kind of like with a file as an abstraction, and you go back, and now you have warehouse features on your object storage. It's a very nice design because the fact that you're in object storage is not a trivial point. You don't have to migrate your data out and in on different systems, so your data always stays in your object storage. So it really reduces your overhead when it comes like to adopting new technologies and migrating into new systems, because you kind of like you now disintermediate the storage layer and your processing layer to the point that ideally, in the wildest dream of a data lakehouse, you can have multiple runtimes engines depending on what you do. And as a matter of fact, like as of today, we do see pretty much like all customers at Bauplan actually use multiple engines. So they use like Bauplan to process certain things, and then they use like Snowflake to process certain others, or they use like Redshift to process certain others, or ClickHouse. So there's this nice thing that you can use like Spark or Trino or your warehouse. But the point is like you ideally should be able to do this like also in Python. The problem that we find with the more like the lakehouse ecosystem is that it's not exactly super simple, frankly. The whole concept of running your data lakehouse is that it seems like the kind of stuff that only large enterprises with very large data teams should be able to do. Because if you go around on the internet and you try to look what the tool chain looks like, it's kind of insane. So you have like this super easy, like there's a bunch of content that's just like, this is super easy. It looked like is you can build a lake house with just like putting together these 17 different tools in this super easy tutorials of like 20 pages. Or just like, oh, you can learn Spark in just like 4 hours and 17 minutes, and like 20 minutes in, we still haven't seen like one single line of code. So just like, well, yeah, like this is simple, but not really. Like this, we can do better than that. And so like I think like a lot of what we do at Bauplan is really help organizations to have all the benefits of this more flexible data stack at a stage where you definitely don't want to spend too much time like learning complex infrastructure. You definitely don't want to spend too much time like learning how to deal with a stack that just to have something Apache Iceberg in the mix will require you to have, Spark sessions just to read and write from a catalog and a bunch of like Spark clusters to do transformations. And definitely we don't want to, we help like we want to help organizations to never have that experience that you have when you manage this divided architecture where you have your orchestration in a Pythonic world. It is simple. It doesn't require you to learn a new DSL or a new system. And then this like thin coat of paint of Python on top of your JVM. And then when something goes wrong, you're back to the JVM. Right. Which I think like this is like more or less our experience, and I think like it does resonate as we see like with many teams out there as the like de facto implementation. So this is kind of like the fracture that you have these days, and we think like there's a lot of overhead that teams have to deal with, and both like if you are embedded in the team, you kind of like have this mental model of going back and forth between two different systems, two mental models, but also if you manage the organization, you often are at the point where you have to understand what are the resources you have to hire for. And a lot of the times like that like goes back to hiring, like data platform teams, even at a stage where I think you could like we can all think of using our resources a bit more wisely than just like getting immediately like a data platform team, just like to manage infrastructure. So what we're gonna do today I'm going to show you how you can use like two very Pythonic tools like Prefect and Bauplan to basically have an entire lakehouse and an orchestration layer that really speak only Python and allows you to not learn a lot other than what you already know. A little introduction about our platform. Our platform is a lakehouse platform for engineering teams who don't want to manage infrastructure. They want to work directly in Python and SQL, and they want to treat data like they treat software with a Git system. The use cases that our customers do most of the time is really good old data transformation. So it's data from the raw stage to the gold stage of an artifact that can be used by a machine learning pipeline or an analytics application or an AI app downstream. So we take care very specifically of that piece that goes from bronze to gold, if you want. And we handle all the infrastructure and all the abstractions around how to organize the data. And it's really Pythonic because you get the nice things of having an iceberg lakehouse at the data execution layer. So you have data versioning that is completely built in. You can use this data versioning with abstractions that are very Git friendly. So you create data branches effectively, like you would with your code, but with your data. And you use those abstractions like you do with Git. Like you have a Git ledger, you can roll back, you have a list of commits. Like it's very simple for people to use this abstraction to go back and forth in time and to isolate their experiments and their runs and their jobs. Okay. But at the runtime level, the runtime that Bauplan exposes is kind of a function as a service. So all your transformation is just a bunch of Python functions really that are integrated vertically with the system, and so has all the optimization that you would expect from a system that is built specifically for this use case, but exposes ergonomics that are very Pythonic. So typically inside of the box, there's, like people have integrations where they take the data from a bunch of sources and they put the data in the format of iceberg tables so they can then transform and do pipelines on it. Those tables live at the storage layer in S3, so people don't really have to migrate or move their data from where it already is, or if they have to do is just like write to an S3 bucket. If they don't have it, it's like a very simple thing to have. And then inside of the box that is provided, you have this Git for data on top of an iceberg catalog and this function as a service runtime over Python that has optimized functions to run computations and run tests. One of the use cases that our customers care a lot about is having data expectations and data quality testing at runtime when they run this transformation between bronze to gold. So you can think of Bauplan as really kind of like a lakehouse platform that takes care of that specific portion and allows simplicity from the developer perspective and robustness when it comes to running pipelines and data tests that you want to work in a way that catches potential problems before those problems reach the final layer, which is SQL engines that speak iceberg on the one hand, or BI tools that speak the Postgres protocol, which is typically how our users consume the data. So what I'm going to show you today is basically this, which is very much what every customer at Bauplan does in production these days, which is using these branches and this Pythonic platform to do the bronze to gold transformation piece. And we're going to orchestrate this with Prefect, and we're going to see why this is like very simple and Pythonic. It's a whole data lakehouse in pure Python if you want. We're going to ingest data, and ingesting data, we're going to create a branch to do that. We're going to create a sandbox copy of the data where we're going to ingest new data, and then we're going to run a pipeline with some data tests to make sure that the data that we ingested and the transformation pipeline is what we expect it to be. And so no faulty data or low quality data ever reaches the production environment. And then if and only if those tests are passed, then we're going to merge that into what we consider our gold, which is our production data lake. All this is just a bunch of Python functions and iceberg tables that are exposed as in Python. And then what typically our users do in reality is usually use a data warehouse for the consumption layer. So there's a handshake between a data warehouse and the final tables that happens with Iceberg. Today we're going to use Streamlit as just like a quick layer to consume the data, just because it's more Pythonic and it's kind of like easier to move around. So let me show you what this looks like in practice, going on our repository. Everything I'm going to show today is on an open source repo that you can run yourself. You can go and check it out. You can request an API key on bauplanlabs.com. Just like get started with your Prefect Cloud instance right away, and you can replicate everything I'm going to show you just like by running this repo. So if you have questions or anything, like I'm here to answer them, but like anything that happens today is something that you can easily replicate by yourself. So the first thing to understand is that the way in which you interact with the data platform that we build is mostly through Python code or CLI APIs. Like this is how, so a lot of the time that the developer spends is in the IDE, which these days plays particularly well with teams that are very strong in using AI assistants like Claude Code. That's kind of a separated conversation that we're not going to go through today, but the IDE is kind of like the primary point of interaction with the platform. So what we're going to do is we're going to start just importing some new data into the platform. So basically, we are here. We're going to take some data from S3 and create an Iceberg table and import some data into an Iceberg table. The first thing we can do is to do that using just a Python function. You import Bauplan, which you literally, just like to make sure that we have everything right. Okay, so it's just like a pip install if you want. And you have like we have here, for instance, like the simple Python function where you have a branch name, and I'm going to walk you through the concept of a data branch in a second. The name of the table that we're going to create and the origin on S3 of the data. Okay, we're going to just like import Bauplan and use a client, and then use some built-in methods like create table and import data.
Could
to just like
I
do
interrupt
this
for a second? Could I ask you to
absolutely
just zoom in your IDE just a little bit?
like this. Oh, sorry.
Yes, thanks so much.
Okay. Oh, sorry.
Oh, yeah.
Okay. So yeah, so the logic of this like should be like fairly simple. So like the origin of the data is in S3. The name of the table that we're going to create is taxi metadata, and the import branch we're going to create is this one. Okay. So the concept of a branch here is this. Let us start by creating one. So we're going to do it like through the CLI. We're going to do like Bauplan, check out branch, and we're going to call the branch with my username as a namespace. And then just like this is our new branch. And if we do like Bauplan branch ls, we're going to see that we are in this branch right now. Now, what branch basically is in Bauplan is just a collection of tables. Right, this is our main branch, for instance. You can go on the UI and check this. Like all these are just like tables that you can see. There's a data preview if you want. There's metadata. You can query them. We're going to see like this in a second. This is how this like a branch is basically a collection of tables that you can see anywhere in your data lakehouse. Okay. So once we created this branch, we basically created a sandbox version of all the tables that we have. So we can make sure now that whatever import we run is not going to touch any table that your downstream consumers can depend on. So we're not going to touch any table that other systems can be reading from. To do this, we're going to just like basically simply run the script like any other Python script, and just do Python oink. And what we get here is, oh, sorry. which is like creating now the data, creating now the new table where we're going to import the data as an iceberg table. The result of this is that we're going to have a table that we can just like query. Okay, so this is done. As I was mentioning before, all you do here as a Python function, potentially you can do, with a very similar semantics with a CLI, right? Like Bauplan table create, the name of the table, the origin of your data. So if like if you do replace, we're gonna do this like with a CLI again. We'll just like replace the table and do this again. Okay. This is the table that we just created. If we go here, now we have, as you can see, our branch, which is not the main, but the one that we created. And this is our new table. This is the metadata, like this is the schema of the table that we just created. And now, because we're importing the data in it, there you go. We have now the data. We want to query this now. It's fairly simple. We just like go here and just do, select star from like metadata. That's it. So that's how you create like an entire, like an iceberg table in your lakehouse. So now we can now start working on this data as a table, no longer as CSV or Parquet files. And we're going to build a pipeline that uses this table that we just created. That's all there is to it, to just like have your iceberg capabilities on the tip of your fingers. So what we're going to do now is we're going to run a pipeline that uses the table that we just created. A pipeline looks like this. A pipeline in Bauplan is just, again, like the import, a bunch of Python functions. This one is a bit different just because it has a minimal DSL with decorators on top of it. Here are the cases. So one is Bauplan.model, which tells us that the function here is going to be run as a step of a pipeline, right? And it's going to choose a materialization strategy. So it basically tells that the output of this function, it takes a table as an input, does some transformation, and then spits a table as an output, following our definition of a data pipeline. And the output here is going to be an iceberg table that we can query in our branch. Okay. Here we define what we need, which is a version of Python, and in this case we're going to be using polars to do this transformation. And very declaratively, we're going to just like tell the system that we want this table, these columns, and these filters to be pushed down directly against the data lake. So it's like using using a warehouse, but in Python. And there's nothing you need to learn about your tables. You don't even know whether this is an iceberg table, as a matter of fact. And the other table that we're going to use is Daxi metadata one, which is the one that we just created. Okay. And then your semantics here is that like the semantics the convention of the pipeline is that now the output of this is going to the next function. So my parent is fed into another function. It's called my child, and my parent plus my child is our data pipeline these days. And my child does the same thing, right? It uses polars, creates a new table, and so on. So if you want to run a pipeline like this in the cloud right now, we can just do Bauplan run. Oh, sorry. I'm in the wrong folder. So I cd into the folder where this script is. Just like do Bauplan run. What Bauplan run will do is read the code that I just walked you through and create separate functions entirely containerized, run them into the cloud as a pipeline. Like none of this happens on my computer right now. Stream back every print statement. As you can see, like there are some print statements here and there, and you can like see them in a terminal in real time, and write these new tables into the branch that I just created. That's all. That's how you run a pipeline in against your lakehouse in the cloud. If I now, in fact, wanted to see the difference between the branch that I am in, to remind me is like, I am in this branch that is called Bauplan Prefect Demo. What is the difference between this branch and my main branch, which is the data that I have in production. Sorry, this is definitely a typo. Is that in this branch now, I have 3 tables, taxi metadata, the one that I imported, my parent and my child, that are the 2 tables that I created by running the pipeline, that do not exist in the main branch. So that's how you run a pipeline. Now, because all of this is just like Python and all the infrastructure is abstracted away, there's a lot of stuff you can do here that is very simple. Like, let's say that I want to change my version of polars and I want to change it entirely, the Python interpreter of this function, this step of my transformation, but I don't want to do it here. Okay, I just changed the code for one of them and I just like run it again. And the system is going to just like rerun this, recreate from scratch the container, and just like without batting an eye. There you go. Right. So what you import inside of your function is entirely up to you. Like every possible package that you want to use to manipulate your data is now available because this is just pure Python. Like here's an example that I can show you is, for instance, I decomment this function here and I just like for a second get rid of my first function. This does exactly the same thing that I just did, but instead of using polars, it uses duckdb, right? So I can just like recreate this like as many times as I want. Do I want to do this like for a larger data set? I can just like change my filter, and now I do this on a much larger data set, 6 months of data instead of 1 month of data. Just like do this again, run it again. It's completely stateless. All you need to know is in this very simple declarative definition of your table. The infrastructure is completely abstracted away. This is going to take a little bit longer because now we're probably doing like a much larger data set. And now we're kind of like, for instance, processing 6 months of the New York taxi data set by just like changing like literally 1 character in our code. That's how people like use usually the system to go from a more interactive development phase to a more production ready phase, right? So this is done. So now we are writing again. We're actually running this on over 100 million rows. And because the runtime is built specifically for this purpose, it's just a Python function for you as the developer, but we can count on the fact that we can use a machine in the cloud that is powerful and use like the bandwidth that the cloud has to move the data around. So it's much more efficient. In 1 minute, I go through, 100 million rows like nothing. So this is literally how you run like an entire pipeline. And there's nothing more you need to learn. There's no JVM, there's no Spark, there's no special DSL that you need to learn. It's just a bunch of Python functions. If you wanted to think about how to orchestrate this, because like all this happens in the terminal, but in real life, this will happen through a system like Prefect. You will use like this Pythonic orchestration flow directly into like handshaking directly with this Pythonic lakehouse. And what you would have is this entire workflow that I showed you through the CLI baked into just like Prefect script where I have, each task uses the methods that we expose. So this creates the branch, checks if the branch exists. If not, it deletes it, creates the branch that we're going to import the data. Then it's going to import the source data and do what we did in the very beginning, creates the table and import the data. It runs the pipeline. So now that I have the pipeline state as a Python object, I can do every imperative logic that I want here, make sure that I can surface informations from my execution environment up into my orchestration, where I keep my kind of like single pane of glass. I verify the output, for instance. I can run a query now by using another method. It's called query to make sure that whatever tables I wrote into my lakehouse is what I expected. And then finally I merge and I delete my branch. So that's what you would do in using something like using Prefect would be just like run this workflow here and view it unfold as just like the workflow that we call from the orchestration layer. I have my parameters here that I pass to the task. I decide to run this in this specific branch, which I can, of course, like programmatically build using timestamps or other parameters. I have my logs and my print statement happening directly into my orchestration layer, and I have like my breakdown in my task runs that is like supremely easy to double check and understand. The end of this, of course, like will give us again the final table that I can query. Let me see. So we're running the pipeline now. Thinking like we kept the 6 months, so we're like actually crunching again through like 100 million rows. What you're going to get finally in your data catalog, obviously, is now, my child and my parent, which now are in main because we just ran the entire job end to end. And if I want to query any of this data, all I need to do is, it's a very large table, so let's do an aggregation. Almost 100 million rows, and that's done. How you visualize this, how you consume this is just an iceberg table. Streamlit is an example of if you want to maintain like this entirely Pythonic way of doing things. So like you can use the very same SDK methods that we have used to create like the entire workflow and orchestrated that in Prefect into something like Streamlit. So this would be our new table, and now I can visualize this. Like when I do fetching data from Bauplan, what I'm doing behind the scene is again a client dot query using just like one of the Pythonic functions that we could use to query this iceberg table. That's all there is to it. Like this is end to end our workflow. We got data new into an iceberg table. We import it. We run an entire transformation pipeline. We publish it, and then we consume it, just like never going outside of Python, not even for a second.
All right. Well, thanks so much, Jira. I've got a question going in Q&A so far. I'm going to give folks some time to ask some questions. I think one thing that leaped out to me was like, so you had mentioned that infrastructure is totally abstracted away. I think this is like, I'm a recovering data scientist myself. I feel like I spent a lot of time trying to figure out exactly like how to provision the right size machine so that my pipeline wouldn't crash at the end of the day. I'm super curious, like how you guys actually solve that problem of like, it feels like you can just like YOLO pipelines at Bauplan and you guys figure out the right way of spinning up the right machine of the right size. Like, how does that actually work?
So this is tied also to the question about the pricing model here. The way in which Bauplan works is that right now there's the ephemeral function. So we provision a pool of resources for our clients, and inside of that pool of resources, modulo the fact that we can auto scale if needed. But like in those resources, the intelligence of Bauplan is the one that will allocate the resources to run a certain pipeline or certain, more specifically, the functions that comprise the pipeline. right? So there's two components there. There's the fact that the runtime here is effectively aware of the data, which is the main problem that I was mentioning in the beginning. Like either you typically like read in your traditional way of developing in Python, you read like entire files into the memory of your system. But in this case, this Python function is hiding a system that is able to do S3 scans effectively. And the other one is scheduling, as in like provisioning the right resources at the right time. Because in reality, folks that use Bauplan in production run more than one pipeline at a time, of course. And so this pool of resources now is also doing arbitrage between all these functions that go up and down, and everything is ephemeral. So like the amount of resources that are needed to process a certain step of the pipeline is allocated for the time that specific step runs, and then it just like goes away and frees new resources that can now be allocated to the next function or another functions or a query that in the meantime came in. But there's a scheduling component as well. The pricing model is based like follows from these premises. And so what you pay for in Bauplan is the resource pool that we allocate for you, which incidentally means that when you run pipelines and you run interactive queries, so in this place here, you will have sometimes you have Streamlit, sometimes like Streamlit, for instance, will run queries, right? Against and we'll use the Bauplan runtime to run those queries that are interactive. The queries are for free. Like you get unlimited queries, unlimited pipelines, unlimited jobs you can run against the system. You don't get charged for that. You get charged for the amount of compute that is a more traditional kind of like a more traditional infrastructure pricing model than what you might be used to if you use something like Snowflake or Databricks, where it's like really per job kind of pricing model.
So I mean that answers my question. I feel like I don't know. It feels like there's some linear programming solver going on in the background, but maybe it's a little simpler than that, I suppose.
I mean, there's also limited what you can do. Like this is Python, right? Like so.
Yeah.
One thing that unfortunately I cannot really do is like prevent you from doing like really really dumb things. So like like if your function like goes in an infinite loop, it goes in an infinite loop. Like there's nothing we can do about it. But there's a constraint on the function that is a Bauplan function is effectively just Python, but it takes a table as an input, it spits a table as an output. That's a little bit of a constraint, and yeah.
One day we'll build software that saves us from ourselves, but not today.
I mean, I thought it was like AI. Isn't that like what AI agents should be like?
Yeah. What does Claude say?
Yeah, exactly.
So we're waiting for more questions to come through from the audience. I'm curious. Like, I think data branching is always a thing I'm trying to wrap my head around a bit more. Like, I try to carry like the analogy just like from Git, I suppose, and even in my own experience, like, being able to branch as a person of one is great. And then like the second you're part of a larger team, you start running into like merge conflicts all the time. Like, what are those analogies in Git for data? Like, what's the actual kind of day-to-day experience? Like, you got 3 data engineers, we're all branching data in different ways. We're trying to reconcile truth at the end of the day. But what does that actually empirically look like?
So very practically, there's two main ways in which you experience like the Git for data as a developer that uses Bauplan. If you're developing like in first person, so you're like literally doing what we did during the demo. So you're creating a pipeline by yourself or using Claude Code, but it's you in front of your IDE and you're actually doing things. So in that case, like you create a branch, you stay in your branch, and then what you typically will do is like try to merge the branch or just like submit the branch for a PR, try to merge that branch. And if it doesn't work because like in the meantime, something changed under the hood, the system right now is very conservative and it will require you to kind of like rerun everything from scratch just to make sure that you don't overwrite production artifacts that in the meantime might have been created. That's kind of like the slow mode. The fast mode is most of the branching actually happens in production, not created by a human, but it's created by a system. Like most of the actual work is done like this, where you have a function that is a task managed by an orchestrator. And so you actually have, hundreds of branches that are created at like every day. And all the branches are, create like this ledger that you can use to go back, check a commit, roll back to a certain state of your lake. But it's a different way of interacting. Like you don't interact with the branches like in first person. It's a machine that creates branches and deletes branches and keeps track of all the commits that happen in your lakehouse, which is what the users use for Write-Audit-Publish patterns, data quality testing. That's the way in which you use the Git for data to basically prevent schema alterations, changes in your sources, data quality issues, a mistake in your code, like anything to create a problem that reaches the downstream consumer. And you try to you can use the Git for data to catch that problem before it becomes like a problem for an analyst or for machine learning person downstream.
Got it. That's helpful. We got a question in about so what's is there a use case for Bauplan to orchestrate DLT and DBT jobs? So really at that ingestion layer, and then also just kind of that data asset orchestration layer.
So DLT is a product that we like very much, and I think like very much is part of the Python brigade. So but DLT in the typical integration of Bauplan these days, it sits here. So it's like it's on the right from where we are. It's a fantastic way of doing things because again, now you literally have everything in Python, like your ingestion, your transformation, your lakehouse management, your orchestration, and your consumption potentially. So we don't need a special integration with DLT Hub. It's just Python, right? And it sits a little bit. It sits on the right end. DBT is different, as in DBT. Right now, we're working on the first integration. DBT for us is just a way to express the transformation. We can run transformation that you express in DBT. We're working on the first connector. The idea at the end of the day will be to have your DBT project, and you can just run that against Bauplan like you do today against Snowflake or Databricks. Yeah.
Hernando had a question, two questions. So first of which is, are there any features in Bauplan to help with data tracing as artifacts evolve? And the second question is really about data governance, which is just any concerns with data going through Bauplan managed infrastructure?
So for data tracing, yes. So the versioning is built in. So if you think, for instance, this might be easier if I just do something like that, and I just do I show you what this API works, for instance, so everything that happens on the sorry. Sorry, I am obviously in the wrong place. Okay, so everything that happens on the lake is traced by this Git for data. The Git for data is not only the branching, but it's literally kind of like a Git metaphor. So you have a ledger now that helps you trace everything that happens in the lake and everything that happens in different tables and different, giving you hashes that you can use to time travel to a certain state of your data lake, given a certain job ID, for instance, right? If you have one specific job ID here, or user ID, you have an identifier, and you can travel back in time to that point. So there's a lot of what we do that is about tracing data as artifacts evolve and make sure that people not only can trace that, I can travel back in time and do backfilling very easily. As far as the governance is concerned, the data is always in your S3 bucket, first of all. So like it never goes in our infrastructure except for processing ephemeral jobs. And we don't shy away from deploying it actually in your VPC. So if you really feel like the data should never, never, never leave your premises, we're okay with that. As far as like access of the data is concerned, now we do the branches are now namespaced by users, and users have write or admin or just read access. So you can kind of like slice and dice your data lake using the permissions of your users like that. Yes, we do support different incremental strategy for loading of the data. What you've seen in the demo, for instance, here is a materialization strategy is called replace, which means that every time you run this job here, this job will take the table that is called my child and is going to just like drop it and replace it entirely. If this becomes like append, this job will append new data to a table that is called my child. So most of the actual applications in real time in real world, as you can imagine, don't actually drop the entire thing, but append data progressively. Yeah. It's like literally nothing you need to handle by yourself. And it's in these terms. Yeah.
All right. We've got a question from Jens, who seems to be a kindred spirit of suffering through PySpark. So one, the first question is, do you support embarrassingly parallel use cases? And then what's the like dependency and packaging look like for Bauplan functions? So like, is it just PyPy? Can you do private artifact repos, GitHub repos? Do you work with PyProject.toml? Like the sort of classical developer experience of
Yeah.
what's the
So
packaging
now it's
you're using?
PyPy. Like now it's PyPy. So like what we like if you like you can publish your own like your PyPy, and that's how folks like have a more customized experience when it comes like to packages. The packages are mounted at runtime, so that's why the containers are so fast and going up and down. So there's some clever hacks that we did to make sure that when we create the containers at runtime, we don't have to go through actually building like an entire container, which is why the experience is like so fast. The from the point of view of um the execution and the parallel execution, you typically what you can typically do, you pass parameters to our pipeline. So the parallelization of your pipeline can happen in your kind of like meta language if you want. If you're talking about like what happens inside of a specific node, again, it's Python, so you can just like multi-thread that as much as you want. Like you can use like stuff like polars instead of pandas. So it depends on where you want the parallel processing to happen. If you want it to happen inside of a node, or if you want it to happen at a pipeline level. If you want it to happen at the pipeline level, you pass parameters to the pipeline, and you run it from an orchestrator. If you want it to happen inside of the node, you use packages that support like multi-threading. That would be like my short answer to that.
All right. Well, we're up on the hour. Really appreciate everybody's time and in joining us. If you want to learn more about Bauplan, you can go to bauplanlabs.com. You can follow Chiro and his
Yep.
entire team on LinkedIn. Oh, we've got QR codes. Cool.
We got QR codes for like trying Bauplan and of course like trying Prefect, and a QR code if you really want to talk to me, which I am incredibly easy to reach. I am usually in Long Island City in New York, and I spend most of my days on LinkedIn and reading emails. So if you want to get in touch and ask me everything, you can just like get in touch.
Yeah, if you joined a little bit early, you probably caught some of Chiro and I's crosstalk of doing an in-person event on the other side of the holidays, sometime in January or February. So if you're in New York City or plan to be, hit us up. Always happy to get together, and appreciate everybody's time.
Thank you very much, Adam, for having me. This has been a lot of
Thanks so
fun.
much, Chiro. Cheers.
Cheers. Bye.
Bye.